Okay, on this worksheet, we're going to explore the mean, also called the expected value, the mean and the standard deviation of a probability distribution. Okay, so for this example, let's say you're playing a casino game with the following rules. You're dealt 5 cards. There's no other players. You win if you beat the hand ace, ace, king, king, queen, which is the strongest possible hand containing 2 pairs. Right? What that means is if you have 3 of a kind or better, you win. Okay, so down here, let's do that. Down here, we'll use this table of poker hands. So basically anything above here. Anything above here is a win. And anything down here, you lose. Okay, now here are the rules. If you're dealt a royal flush, and we have the probability for a royal flush, you are paid $200 for every $1 you bet. If you have a non-royal straight flush, which is the second line on this table below, you're paid $100 for every dollar you bet. So a royal flush pays 200 to 1. Royal flush pays 200 to 1. A non-royal flush, so let's actually put that here. This one pays, so the payoff odds are 200 to 1. A non-royal straight flush pays 100 to 1. Okay, 4 of a kind, which is the next strongest hand, that pays 50 to 1, $50 for every $1 bet. And for any other winning hand, of which there are 4 of them, these 4 hands pay $25 for every $1 you bet. And if you have a 2 pair, 1 pair, or high card, you lose your bet. You lose $1. Okay. So, questions. What is the expected value of this game? Now remember, expected value is the same as the mean. So what is the mean of this game? And what is the standard deviation? Okay, and then once we have that, once we've answered number 1, we could answer number 3 and 4. If you play the game 1,000 times, betting $1 each time, what would you expect the overall outcome to be? How much money would you end up with? Okay, and after you answer 1, 2, and 3, in your opinion, is this a game you would want to play? Why or why not? Okay, so basically I've copied all of this over into an Excel template, and let's solve the problem over here. So in this large blue box, I've just copied the rules up here, and I've copied the questions down here. All right, so we have, let's see, let's switch to green. Okay, so we have formulas down here for the expected value, E of X, which is also the mean. Let's make that a little better. So the expected value, which is E of X, or mu, and that's this formula right here. The sum of X times P of X. The sum of X times P of X. Okay, so the probability, I'm just going to copy these probabilities. They are given to you. Okay, so copy and paste. Oh, it took away the color. Let's bring that color back. There we go. Okay, so we have the probabilities. Now, if you bet $1, what are the possible outcomes? Well, over here, if you bet $1 and your hand is a royal flush, and I'm just going based on the directions down here. If you bet $1 and you have a royal flush, the outcome is 200 plus $200. Okay. If you have a non-royal flush and you bet $1, your outcome is $100. Okay, that's number 4. Number 5, if you're dealt 4 of a kind, you're paid $50 for every $1 bet. Okay, so the outcome would be a positive 50. You're paid $25 for any other winning hand. So a full house, your outcome would be a positive 25. A flush would be positive 25. A straight would be positive 25. And 3 of a kind would be positive 25. So right here, meaning that you win with 3 of a kind or better. Okay, so if you don't win, you lose. So anything below 3 of a kind, you're losing your dollar. You're losing your initial dollar. So that's a negative $1 for 2 pair, because you're losing your dollar. A negative $1 with 1 pair, and a negative $1 with high card. Okay, so now we have our outcomes in terms of dollar amounts and the corresponding probabilities which are given in the problem. Okay, so this formula for expected value says we have to take each x value times its corresponding probability. So x times p of x, and then we'll add them up. And that's what I have here in a column F. So for each x value, we need to multiply by p of x. So using Excel, let's say I'm in location F3. Location F3, I want F3 to be equal to the 2 numbers to the left multiplied together. So I want the product of these 2 numbers. So I want D3 multiplied, shift 8, multiplied by E3. Okay, so it's basically each cell in column F is going to be the 2 numbers to the left multiplied together. Okay, and let's let Excel do the rest of them for me. Okay, so now what we have here in column F are these individual x times p of x values. Okay, and now, so multiplication first, addition second. So now we can apply the summation, meaning add them up. Okay, and that's it. Equals the sum of these individual values. And there we go. That's the expected value. So negative 0.246, or round it to the nearest penny. Let's round this to the nearest penny. Okay, so about negative 25 cents. That means for every dollar you bet, you lose a quarter. So that's over time what you would expect to happen. It has nothing to do with if you played the game once or twice or 5 times, but if you play the game hundreds of times or thousands of times, all those wins and all those losses would average out to about a loss of 25 cents for every dollar you bet. Okay, so that does it for number 1, question number 1. What was the expected value of the game? Well, the expected value of a game is losing 25 cents for every dollar you play. Okay, so now standard deviation. So now we're down here. Standard deviation. So we need each x value minus the mean, and then we square that. So each x value minus the mean squared. So that's what I have here in column G. X minus the mean. So our x values, don't forget, our x values are here. So we want to take each x value minus the mean. So I want to take 200 minus the mean, then 100 minus the mean, then 50 minus the mean. And for each one of those, once we subtract, then we have to square. Okay, so let's do it once. let's do it once here. And then we'll drag it down and let Excel do the rest of them for us. Okay, so up here in cell G3, let's just type in exactly as we want. We want this. We want the x minus the mean quantity squared. And then we'll deal with the times p of x in the next column. But right now, just x minus the mean squared. Okay, so in parentheses, I want the x value. Oh, we need an equal sign. Don't forget the equal sign. We want the x value. Goes parentheses. X value minus the mean, close parentheses, raised to the second power. Okay, now, there's a problem with this, because if we do this and we drag it down, then the D3 will become a D4, and then the next one will become a D5, and then it will become a D6, which is what we want, because this is D3, D4, D5, D6. So as we pull the equation down, we want Excel to use these different x values. But the F13, that's right here. When we pull this down, that F13 will become F14, which we don't want. That's the word's expected value. And then it'll become F15, which we definitely don't want because there's nothing there. And then F16 and so on. So we don't want that. What we want is when we pull this equation down, we want F13 on the second, for the second calculation. We want F13 again and F13 again every time. We want the same F13 because we want to use this mean each time. And don't type in negative 0.25 because it's not negative 0.25. It's only rounded. It's only rounded to negative 0.25. I mean, if we take this and we increase the decimals, well, that's definitely not exactly negative 0.25. We just rounded it to the nearest penny. But Excel is not using the rounded value. When in our calculation, Excel is going to be using the exact value. Okay, so we use the dollar sign. We use the dollar sign. It's the freeze function in Excel. So we want this to equal the x value minus the mean. And we want to freeze the 13. So if you put a dollar sign before the number 13, Excel will freeze the number 13. So when we drag it down, the D3 becomes a D4, but the F13 stays F13. Okay, that's what we want. And we'll raise that to the second power. Okay. And so now when we pull this down, Excel will do the remaining calculations for us. Okay, let's get rid of those. Okay, so now coming back down to this formula. So we did this first. Now, I need this. We did this first. Now let's multiply by P of X. Okay, let's multiply by P of X. So here is step one, X minus the mean quantity squared. And now we want to multiply by P of X, which means we want this number, X minus the mean squared, times this number, the corresponding probability. Okay, so let's do it once and have Excel repeat for us. So we want this X minus the mean squared. We already have that. That's G3. And we want to multiply by the probability, which is over here in E3. Okay, we probably want to round that to 3 places. Remember the mean and the standard deviation, so technically we should round this also to 3 places. The rounding rule for mean and standard deviation is 1 more decimal place than your original data, and our original data is to the nearest penny. Okay, so we'll drag this down. All right, now we've done the x minus the mean squared. Then we've multiplied each one of those by p of x. Now, finally, we have to add them up. And that's what I have here in blue. You see the word sum. So right here, we want to take all these numbers here and add them up. And that answer goes right here. So again, we'll use the sum function just like we did for the expected value. Let's type in equals the sum, parentheses. We'll take the sum of all of these numbers here, all the values above. Okay. And so what we have here is actually the variance. Now we take the square root of the variance. And so in this formula down here, again, step 4 is the square root. So we take the square root of that sum. So equal. Square root is SQRT. SQRT is the Excel function for square root. Square root of the number above. And there is our standard deviation. So just like earlier in the descriptive statistics, the mean and the standard deviation of the frequency distribution, Excel does not have a one-step built-in function for that. Same thing here with the mean and the standard deviation of a probability distribution. We have to sort of do this half manually in stages by applying the formula on Excel. Okay, so that about does it. Well, that does it for question 2. Now, if you play this game 1,000 times and bet $1 each time, what would you expect to happen? Well, you would expect to lose. So I'm going to use this rounded to 3 decimal places. You would expect to lose this much money 1,000 times. You would expect to lose 24.6 cents approximately 1,000 times. So if you multiply these two numbers, you would expect to lose $246. Okay, so for number 3, again, this expected value, according to the law of large numbers, this expected value tells us what's going to happen over time when you average out all the individual fluctuations in the results of the individual experiments or the individual trials. In your opinion, is this a game you would want to wager money on? Probably not. This is a pretty bad expected value. Even the worst casino games, the expected value is only like a negative 5 cents, negative 6 cents, something like that. So almost a negative 25 cents per dollar. That's a very, from a probabilistic standpoint, that is a very, very bad game to play. Okay, so you could use this Excel template and adjust it to and to apply to homework questions. But in general, this is the this is how we find the mean, the expected value, and how we find the standard deviation of a probability distribution. With some exceptions, there's some shortcuts depending on different types. So in general, this is how you do it. In the next topic, in the next video, we'll talk about a specific type of probability distribution, the binomial probability distribution. And specifically for the binomial distribution, you don't have to do any of this. It's a much, much shorter process. But unless you're talking specifically about the binomial distribution or maybe the Poisson distribution, this is how we do it. This is how we calculate the mean and the standard deviation. Okay.